Okay, so we have discussed and worked with the 5 different ways to prove triangles are congruent. Side, 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 angle, 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 side, and hypotenuse leg. So we know these are the things. The second column is what needs to be true for us to be able to prove it using that theorem or postulate. So for example, side, 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 there should be 3 pairs of congruent sides. So what I want you to do on the third column is you're going to mark your triangles, how they should be marked with either side dashes or angle arcs so that it is showing that postulate. So for example, side, 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 in the 2 triangles, I should put 3, like that side matches up with that side, those 2 sides are congruent, and those 2 sides are congruent. So that's what I would need to see in markings on my triangles in order to say they are congruent by side, side, side. So I want you to go through the last 4 theorems or postulates and make the correct marks on each of the triangles for those 4. Does that make sense? So I'm going to give you a minute or 2 to do that. Okay, so for side, angle, side, that means we have to have 2 sides and the included angle shown as congruent. So if I'm going to say that this side is congruent to that side and this side is congruent to that side, then the angle that I have to show as congruent would be that top angle. Okay. Maybe we have different possibilities here. Maybe you chose to do this side is congruent to that side and that side is congruent to that side. So the angle that would have to be congruent would be the one in between, the included angle. So we have 3 actually varieties or variations to this. But what you need to be sure is that you have 2 pairs of sides congruent and the angle is the included angle. Angle side angle is kind of the reverse of side angle side. You first need to show 2 angles are congruent. So if I say that angle is congruent to that angle, and then that angle is congruent to that angle, the side that is congruent needs to be the one in between those 2 angles. So then I would have to say that that side equals that side. So maybe you did maybe you did this angle equals that angle. Those 2 angles are congruent, then you would have those 2 sides congruent. Side has to be in between the 2 angles. Okay, angle, side, again 2 angles and 1 side. You pick, so if you chose to say that these 2 angles are congruent and those 2 are congruent, then the side has to be not the included side, but it's got to be the same on both. So if I'm going to say this side, I'm going to match it with another side on the other triangle, I could not use this side because notice they aren't the corresponding side. This side is with the 2 arcs and the no arced angle. This side is involved with the 1 arc and no arc. So they're not corresponding. So angle, side, the side that you mark, the pair of sides that you mark as congruent, they need to be corresponding. So that would have to be this side in this case for choosing those. Hypotenuse leg, we talked about that the last couple days. We have to show that the hypotenuse is congruent and then one of the 2 pairs of legs. So either that pair or the vertical pair. Okay? All right, so now we're going to be working with proofs. And we did a little bit of proofs earlier in the year. They were more of the algebraic, where we were solving an equation and proving that x equaled some value. Now we're going to be working with geometric proofs. Here are some of the reasons that we can use, that we might use to say that sides are congruent. Number 1, it could just be given to us. We could have information about a point being the midpoint on a segment. So a midpoint cuts it in half, right, into 2 equal parts. So that would be 2 sides that are congruent. Or we have reflexive property. We've worked with that a lot already. Angles might be congruent if it's given information. We've worked with vertical angles. Or we may have 2 parallel lines cut by a transversal, which would give us these 3 pairs of congruent angles. Or we might have information that says an angle is being bisected. So that would be like number 3 on our bell work. That angle is bisected, cut in half into 2 equal parts or 2 congruent parts. So we may use that. We have talked about CP, CTC. Corresponding parts of congruent triangles are congruent. And just as a review, if we know that triangle ABC is congruent to triangle DEF, then I want you to list the 3 pairs of angles that have to be congruent and the 3 pairs of sides that have to be congruent because of CP, CTC. So take a minute to do that here. So these 3 pairs of angles will be congruent if the triangles are congruent, and then here's your 3 pairs of sides. Side AB, which the first 2 letters in this will be congruent to the side that has the first 2 letters in the second one, which would be side DE. BC is congruent to EF, AC with DF. All right, let's move on to the next page. Write the 3 side congruence statements here based on the information we have here. So side AB is going to be congruent to what side in the second triangle based on the dash marks on the sides. So 3 pairs of sides, and then on the last line, then you're going to write the triangle congruence. So triangle what is congruent to triangle what. That's what you want to do in this blank. So take a minute to do that. So kind of repeating what we did on the last page, but for side, 3 pairs of sides have to be congruent. Based on this picture, here are the 3 pairs that are congruent. And because there are 3 sides that are congruent, 3 pairs, we can say that triangle ABC is congruent to triangle DEF. Now, it won't always be alphabetically, so don't just assume that that's how they will match up. ABC starts at A, goes through the 1 dash, and then the 2 dash side. So the same has to be true for DEF. We have to go to the 1 dash, 2 dash to name that triangle. Follow the same pattern. All right, so now we're going to do a proof. The first thing you need to do is, we will be given some information, and then we want to prove something. So proofs are great for their logical thinking, their critical thinking. They're going to help you in all facets of life. Basically, what's happening here is you're given some information, and you're going to give a step-by-step proof verifying that this is true. So sometimes it's not enough just to say, hey, this is true. Well, how do you know that's true? We have to have some facts behind that so that we can justify the answer or what we're trying to prove. So in the first couple of proofs, they are going to give you the statements. And most of the time, you're going to start with one of your given statements. But before we even do that, let's look at our given information and make marks that we can on our triangle. So it tells us that PQ is congruent to ST, so I'm going to mark that. PQ, ST. Those 2 segments are congruent, or sides. It also says that QR is congruent to TR. So QR, TR, I'm going to give it 2 marks. And then we'll use the midpoint stuff later. All right, so we want to prove that these 2 triangles are congruent. First, we have to get what we know. So we know PQ is congruent to ST. How do we know that's true? It's given to us. So our reason for saying that is because it's given information. QR is congruent to TR. That's statement number 2. How do we know that is true? It is also given to us. And then the third statement is the last piece of information that is given. R is the midpoint of PS. That is given. Okay, so statement number 4 says PR is congruent to SR. How do we know that? Okay, so remember, there are several ways that we will be able to show that sides are congruent. Either it's given information, it might be the definition of midpoint, or it might be reflexive property. Well, it is not reflexive property in this case. They don't share a side. But our given information tells us that R is the midpoint of PS. Midpoint cuts a segment into 2 equal parts. So we could say, mark our figure, that those 2 sides are going to be congruent. And that's the next statement in our proof. Why are they congruent, though? They're congruent by the definition of midpoint. Now, the last statement is what we're trying to prove. Do we have enough information to say that those two triangles are congruent? By what postulate or theorem? Side, 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 because we've shown 3 pairs of sides are congruent. And because this says sample side, side, side proofs. So there we go. On our next proof, we are going to prove the 2 triangles are congruent. We have some given information. Right away, I can label or mark my figure JL is congruent to NM. So I've done that. Then I have some other information that'll probably help me mark up some of the figures further. First statement, JL is congruent to NM. How do we know that? They gave it to us, so it's given. The second statement is that K is the midpoint of those 2 segments, which means that was also given to us. Okay, so let's figure out if K is the midpoint of JN, J to N, K is the midpoint. That's going to cut that into 2 equal parts, so those 2 segments will be congruent, correct? And that's what we have in number 3 statement. JK is congruent to NK. How do we know that they are congruent?
Midpoint.
Definition of midpoint. I know, man. Definition of midpoint. I'm going to start coughing again. Okay, so now LK is congruent to MK, right? How do we know that?
Definition
Of midpoint. Do that twice here. Oh my goodness. So we can do that and we can mark that. So do we have enough information to prove that the 2 triangles are congruent?
Yeah.
By what?
Side, side.
Thank you very much. Let's stop this recording. We know that AC is congruent to AD, so I'm going to do this. Right? And we know CB is congruent to DB, right? So let's mark that. Hey, they didn't give us the statements in this one. Okay, so what do we start with on our statements? We always put down the given. So we're going to put the first given, AC is congruent to AD. And that's given. And then CB is congruent to DB. That too is given. Now, is there anything else we can conclude about this figure? Looking at it. By what?
Definition of midpoint.
Reflexive. They share that side, right? AB? They share that side? So we can say AB is congruent to AB. And by the reflexive property. Oh no, it's going to happen again. Oh my gosh. I'm not putting this video on.
Yeah, you have to.
And then, do we have enough information to prove that the 2 triangles are congruent?
Yes.
So we can just use that statement right there. Triangle ABC is congruent to triangle ABD by side, side, side. JM is congruent to LM. So that means I'm going to put a mark there and there. And then angle JMN. So I'd start with J, go to M, go to N. That would be this angle right here. Is congruent to angle LNM. Start with L, go to N, then M. There we go. We know that much first, right? So those are the first 2 statements in our proof. Let's just put what's the reason for both of those? How do we know JM is congruent to LM? That's given. We also are given the fact that those angles are congruent. So now the next step is that they share this side, right? So can we say that it's equal to itself? Yeah, what's the reason?